I'm DellArio, and I'm with Ario, a Seattle startup. And today I'm going to talk about a relationship that I discovered when I was studying one of my favorite topics, solid-state lighting, about 3 years ago. And that relationship is a three-way relationship, and maybe not what you think. It's the relationship between health, light, and connectivity. So, like any well-run machine, our body's equipped with a clock, and that clock controls a whole variety of processes in the body that are important to your health. And those are alertness or sleepiness, when you get hungry, digestion, blood pressure, a whole variety of things. And the clock expresses itself through the production of hormones. The primary hormone is melatonin, and the clock operates on a light-dark cycle. And the connection from the body or from the external world to that clock is through some receptors in the eye that were only discovered as recently as 2002 that are non-visual and sensitive to blue light from above, and not so very sensitive to reddish light from below, which we'll see later is important. For most of man's time on the planet, the only light source aside from the moon is the sun, and the sun changes color throughout the day, so it's variable in color, variable in blue content, and notably absent at night. The first artificial light was the candle. About 5,000 years ago, man came up with the candle, which is has very little impact on circadian rhythm, warmish color, and aside from the fire danger, relatively safe to your health. In the early 1800s, Humphrey Davy invented the electric light, and that was later commercialized by Thomas Edison. The thing that's interesting about the electric light is that it's more efficient than a candle, but also more blue, which we'll see is the start of a trend. The GE brought us the halogen incandescent light, and the halogen lamp is yet more efficient and yet more blue, followed by the compact fluorescent. That's a fairly recent invention, similar to these, well, maybe these are LEDs, but similar to the long fluorescence, more efficient than halogen lighting, but also more blue than the halogen lamp. And then finally, as you all know, LEDs have just come on the scene. Although they were invented a while ago, they become commercialized as sources for lighting. And they use a blue LED at the core of a white light. They're available in a variety of colors from warm to bluish daylight, much like fluorescent lights, but they have yet more blue content than any of the other light sources, and much more than a candle. So it's been kind of a gradual trend toward efficiency, with significant change that way, and significantly more blue that we're exposed to from these light sources. So why is that important to us? Blue light during the day is great. It synchronizes our circadian rhythm, particularly if we're exposed to it in the morning, and it raises levels of cortisol right after waking, so it helps us be alert, and that's great. But at nighttime and even in the afternoon, if there are substantial amounts of blue light in the environment, particularly in the evening, it suppresses the production of melatonin, which I mentioned earlier is one of the main regulating hormones in the body. And of course, we don't feel any of this stuff happening. But I guess if I'd like to see a show of hands of people that have on the weekend partied for maybe Friday night and Saturday night, and then had difficulty waking up on Monday morning at the usual time. Anybody here? So, there are a lot of things that go into that, but scientists describe that as social jet lag, and it's a consequence of blue light's impact and blue light's ability to synchronize our circadian rhythm. But in the case of light exposure at night, it's mis-synchronizing our circadian rhythm. The effects of shifting and shortening the amount of time that melatonin is naturally produced in the body, the main one that you would notice is that it might be more difficult to sleep. And according to CDC, 10% of Americans suffer chronic insomnia, and 25% of adults self-report that they have difficulty sleeping. And I could ask for, again, a show of hands whether any of you ever have difficulty sleeping, but I think it's a pretty common problem. What is less apparent is a whole series of silent impacts. There have been links between these changes in hormone production. Poor sleep, I said that already. Diabetes, breast cancer, impaired cognition and learning, a higher incidence of serious and fatal accidents, immune deficiency, and there are a number of other health issues linked to these changes in hormones. And we haven't heard much about this. Most of these studies have been conducted in the past, well, since 2002, a lot of them at Harvard and Rensselaer Polytechnic back east that have been looking at these effects. Researchers postulated quite some time ago and noticed that the circadian rhythm is linked to a light-dark cycle, and it's only been the discovery of those photoreceptors that I mentioned recently that that were implicated in the actual cause of these particular changes. So it's a significant and yet largely unrecognized problem. There are the lighting manufacturers, some of them recognize it and talk to it, but there really aren't any products out there that address it. We've seen products that are connected but still aren't set up to address the particular problem. So what are the characteristics of a light that would be ideal? In the daytime, it'd have a rich blue content like the sun, and at nighttime, safe, low blue concentration light like candlelight. But what really makes it work are the controls that make the light automatic, and those controls allow you to flick the switch and turn the light on and have it be the right color at the right time of day, regardless, which means an onboard real-time clock. You want the onboard programming not only to mimic natural daylight and color and duration, but also be able to personalize it. So you can take an advantage of a variety of technologies, machine learning. If you control the light yourself over time like a Nest thermostat, it can learn your patterns and adjust the onboard program. But if you have a series of lights throughout the home, maybe you're only using one or two of the lights frequently, and you have some others. How do the lights share information? And that's really where Internet of Things helps out, because you can, well, I'll describe a little more later some of the features that you can get as a consequence of this. Looking at the spectrum, in the center is the sun at noon, and you'll see that there's a fairly continuous spectrum rich in blue light. And if you're building an artificial light, it's very difficult to get the intensity of the sun. So what you want to do is bump up the blue light and really take advantage of the extra blue light that LEDs offer during the day. And then it's possible to create an LED that's very low in blue content, which is what we've done with our product. And then you can shift with these intelligent controls between this super blue LED, intermediate white LEDs into this candle-like light at night. And this is probably a good time to show you a demonstration of this particular light that's an example, and it's going to cycle through a 24-hour day in 70 seconds. This would be a nighttime light with red light delivered in the downward direction, and it naturally will cycle. This would be like this all night long, and then at sunrise the light's cast in an upward direction and both directions, lighting the whole room up like being outdoors as nearly as we can make it. And then the light becomes more blue throughout the day, and then that cycle reverses itself. If I can set my phone up as a Wi-Fi hotspot here, I can demonstrate that, in fact, if you have wireless controls, you can talk to these lights. But I first have to set up the Wi-Fi hotspot to do that. So if you'll bear with me, I'll go into settings and make that happen. I'll talk about some of the challenges of actually implementing Internet of Things in a commercial product in a couple more slides after I get the demo going. For this demonstration, what we're using for your interest is a little Spark core, which is kind of a cool part that's Wi-Fi enabled and connects to the cloud, but also will connect to anything that's nearby. And it is connected, so okay. So as in any good demo, if your features aren't working, you go to the manual switch. So what the user can do, and the actual product will be configured in this manner, is we have switches that will allow you to turn the upper light on in the evening so that if you've got an activity or you've dropped your contact lens, you have sufficient light in the room to find things, for example. Or you can control the color or the intensity of the light. So here we're changing the color dynamically. And here we're changing the intensity dynamically. So you can see that it's possible to create a fair level of light within the room.
I had a quick question.
Yeah.
Will your environment actually alter the color of the light? Like, let's say you had gray walls or green walls, and the light's reflecting off of this. Will that somehow alter the color or the spectrum of that light?
It's always true that some of that's going to happen, but what's the chief concern is at night and blue light exposure. So if the lamp's not emitting blue, regardless of the color of the environment, there'll be little blue. So it'll have little effect on your circadian rhythm. If you were in a room that was, for example, a dark red, the impact of the blue-white light for purposes of synchronizing your circadian rhythm wouldn't be as effective. So that's true. What you're saying is true. Philips has a TV set that has a light on the back of the set that lights the wall and senses the color of the wall and changes its color so that the TV looks right. And we don't have that particular feature, but I thought you were going to ask about another one. Did I answer your question, first of all? And that's great, because this is the next slide. To make a lamp like this easy to use, you really need stored programming, and this is the problem with most lighting products on the market today. There's no local storage of a program, so you have to use your phone. When you first turn the light on, it's going to come on at some default color, or it's going to turn on at the last color that it happened to be. It needs a way to know what time of day it is, too, so you need a real-time clock in the product itself. So these are all local controls that of themselves don't depend, except for the real-time clock and its synchronization, on being connected to anything. But if you are connected, then you can do things like accumulate data like a Fitbit in the lamp and then upload that data to a website and use that for storing user metrics. But more importantly, you can have it interact with programming on the website, and some of this can happen locally in the lamp if you have enough processing power, but it can shift the program within the lamp to make it personal. You can also detect the presence, 1 minute, okay, of the user, and you can do all these other things, do user remote control, but the main thing is that you can use this connectivity to communicate between the lamps and a web-based app to affect personalized control and have the lamp respond to changes in the environment. So I'm going to gloss over those slides that show that you can shift the timing of the light to help you for things like prevention of jet lag and get you adjusted to other time zones, or if you're a shift worker. And there's a ton of different ways to connect things together. And I'm just clicking through them. But in this wide variety of ways to hook things up, it's difficult to select. And what we've chosen to do is to put a Bluetooth low energy radio forming a mesh network so that we can also do proximity detection, and we have Wi-Fi radio in the lamps so that a self-appointed master can talk to the web. So we get all the connectivity that we want to create the features that we like, and we solve some of these problems with our internal clock, phone controlling of lights being a problem, and Internet of Things hardware being very costly. Really the only thing that you can do about that is work really hard and look for cheaper solutions and basically do a lot of development work. So the things I'd like you to take away is that light at night, traditional light, has significant health impact. Internet of Things can help make solutions like this work well. You really need autonomous control, though, because direct control via radios still a problem. And notice arioliving.com go to our website, and if you have any comments or you want to be added to our email list, we've got a little button at the bottom where you can do that. So thanks very much.